Perfect. Welcome to AWS Public Sector Summit. I'm Jeet Shangari. I'm a Senior Technical Account Manager working for AWS for about 2.5 years now. And today I will be talking about how to operationalize your AWS infrastructure by leveraging some of the infrastructure as a code and automation principles. Here's the core agenda that we will be covering today. We will start with some of the common challenges that we have seen many industries faces today. We'll talk about how you can resolve some of those by using infrastructure as a code and what are its core tenets. What is infrastructure resource lifecycle and how you can operationalize it in your AWS infrastructure by doing more and more automation across the lifecycle. So let's get started. The software creation and distribution is easier and faster than ever. We have seen several industries in the recent past has been disrupted in a good way by several startups and who are taking on giants in a big way with little to no funding. So prime example of those startups are Airbnb of the world in the hotel industry, Netflix in media industry, and Uber in a transportation. And it's very easy for these startups these days to try out new features, new enhancement, new concepts, and roll out as a part of the overnight updates, as a part of application update that we all have in our phones today. We all have a couple of devices at least in our pockets these days. And it's very easy for these new generation companies to be more agile and leaner to try out those and target certain customers and try out those features and take that feedback from a customer perspective and change the way they want to do business, right? And getting your software into hands of millions, it's a download away these days. So we should leverage that. And this talk is all about how you can actually get some of those automation going so you can actually operationalize and take more 360 feedback from the customer. So according to a survey from Forrester, the average lifespan of an SMP company has now dropped from 67 years in 1920s, about 90 years ago, to just 15 years today. And according to the same survey, it's about 2/3 of the IT budget still goes in keeping the lights on, meaning that maintenance mode, application running, you're not doing any innovation, no features being developed, just to keep the lights on. And unfortunately, the CEOs believe security risk has increased in the last few years because the risk management capabilities are falling behind. So how does this impact you? For the technology leaders, this climate has material effect on your ability to operate. And you are left out with almost no resources to pursue any critical business needs or new innovative product, try out new features, and your IT model lacks agility, right? And you have insufficient security and compliance. And even the best effort security operation may not be able to identify and remediate any potential risk. So it's a kind of a very difficult situation to be in, especially for the big giants. So responding to this change requires a new model of engagement for sure. And we are looking at many companies. Some of those are big giants that I referred earlier in the slide. They are looking at cloud to double down on the investment to support their core mission so they can focus on their own business and help their customer instead of spending a lot of time and energy and dollars in keeping the lights on. So infrastructure as a code can address some of these deficiencies by bringing automation to the provisioning process from the time you provision a resource to the time it goes through the entire cycle, and we will talk about in the future slide. And it really helps out and improve on a lot of automation processes by increasing the delivery process and being more agile for the organization. So let's talk about what is infrastructure as a code. It's a way of provisioning resources in a repeatable and a consistent manner, and there are many tenets that goes into it. The foremost is there has to be a single source of truth. It has to be a single template which can be deploy and manage the entire stack, not just one instance. Basically, the entire stack of your production that includes your EC2, S3, any databases that you're using, anything that involves in the stack has to be in a single source of truth. The infrastructure that can be replicated, redeploy, or repurpose. Basically, you should reuse that template across all the phases of software lifecycle. You should be able to use for development, testing, staging, and all the way to production. It should contain all the attributes, including network storage, servers, anything that requires to build that stack. The other thing is you want to treat that infrastructure as a code, just like your application. You should version control that. You should have a CI/CD lifecycle on your build and manage. And we will go over some of those advanced features as we get into deeper into the slides. And at the end, you should be able to have a compliance check as a part of your monitoring solution and performance management. Before we get into some of the deeper aspects of on ISC, let's talk about what is the infrastructure resource lifecycle. There are 5 stages that goes into play when you are deploying your resource being an EC2 instance or S3 bucket or so forth. When you're deploying in AWS, it goes through 5 cycles. So first is when you're provisioning that resource, and the second, when the resource become a part of your configuration management system in AWS, and you want to support activities such as tuning, patching, and so forth. The third is that's where you want to have some monitoring solutions to manage your performance and have some automation around how to automate certain events whenever there's something happens on your application server. And the fourth being, which is the heart of this audience, I believe, which is governance and compliance. So how you can actually apply some of the compliance as a code, if you will. For example, if you're on GovCloud, how you can get FedRAMP ready, how you can do HIPAA if you're in healthcare industry, how you can actually automate all of that as you're building your stack on the cloud. And last but not the least, the resource optimization, how you can save money once your resource is running to optimize for cost, efficiency, and performance. So let's begin with the first stage of this resource lifecycle. And I don't expect you guys to read all of this, but the basic idea here in this slide is to give you an idea some of the use cases that goes around resource provisioning. Whether you are a manager of an IT firm where you need to provide a consistent development environment or a testing environment, or you're a release manager where you want to build a replica of your production environment to do a blue-green deployment. But the idea here is there's a need to have a repeatable and consistent process for instantiating resources in AWS. To address these needs, AWS offers CloudFormation, which enables provisioning and management of your infrastructure as a code. So what is CloudFormation, right? It's basically a JSON and YAML template, right? And you present this template to CloudFormation service within AWS, and CloudFormation internally translates that into various API requests depending on what resource you're trying to spin up, and this forms a stack of resources, right? So if your stack includes a bunch of clusters using EC2, whether it's a spot or on demand, or whether you have various databases running, DynamoDB, Aurora, you name it, you can all define that in the template, and CloudFormation can run that in parallel without any issues because it can identify those relationship and dependencies by default. It's a free service and it's available in all regions, and APIs are called in parallel, as I mentioned, because you don't have to worry about sequential execution. So let's look deeper into the template. What are the various attributes that compensate into the template? There are many of those, one of which is metadata, which specifies the JSON objects that provides additional information about that particular template. And the other one is mapping, where you're specifying values that you can pass it in your template runtime. The ones which is most important attribute here is resources, which is required and mandatory because this is what you're spinning up on AWS. So this is where you will specify the stack of resources and their properties, such as EC2, S3, you name it, the way I mentioned in the previous slide. So let's look further one level down into the sample template that creates an EC2 instance, right? It's a very basic template. This is where you will be asked to enter values for these parameters, right? You can actually add on to any of those parameters. The most important here is resources, which include statistically defined properties, and you can actually have an image ID, which is AMI, or we call it as AMI, which is specific to the region itself. So in this particular case, if you see AMI 9D23 something something, that's very much specific to EU West 1 region. And then the output, this is where you will define what to expect as an output in the return, and what situation you will consider that template to be failed at the time of execution. So that was a basic of CloudFormation, right? Now let's get into some of the advanced features related to security, because that's on the top of everybody's concern, especially when we talk to GovCloud and large enterprises and big giants that we mentioned earlier. So there are many ways we can provide guardrails, and we heard many times in the last few years from various of our customers that how can I protect my stack once I start using CloudFormation? How can I protect that from accidental deletes? Because that has happened to some customers, not in the recent past because we automated some of these things, but initially, right? But there are a few guardrails that you should be considered while you're using CloudFormation, and there are 4 of those. The fourth one, which is in the list here, is a very common way which we have seen our customers using from the users and roles perspective, where they control who can use specific template and resources. Right? That's a very common way we have seen customers using that, but there are other ways which are not as common, and that's where we want to go deeper dive into. So you can have a fine-grained control for critical resources, which is at the resource by resource level. It's a most granular way where you can define each resource within the template, who should have access and stuff like that. And you can also have a stack level policies to implement restriction on the group of users, if you will. And the very first one, which is you can lock down the entire stack, where you cannot actually change anything in the stack, and it's very important control which we introduced I think last year for mission critical production workload, where you want to make sure the entire stack is locked down and it should not be changed by anybody except in certain cases in exceptions. So let's look at one deeper level on what is that stack termination protection. It's very easy to enable at the stack level if you go to the advanced settings from your management console, and if you see in the bottom there is a termination protection which you need to just enable, and you can actually verify that from the overview on that particular stack whether it's enabled or not. It's a very much recommended for critical stacks, and let's get deeper into some of the other policies that you should be doing. In this particular case, we are having a guardrail at the stack level policy. So if you look at this JSON, we are basically denying any updates on this stack when it comes down to RDS instances, right? All other updates are allowed, but not RDS, because RDS is a critical component in this particular stack for the production workload. So you can actually define at that level as well. You can do at the resources level, as I mentioned earlier, but that will be a really granular resource by resource. In this particular case, you're just having a deletion policy for backup and snapshot on your EC2 volume, and all other things will be acceptable. And then IAM policy, which is a very common use case, which we have seen our customer consuming. In this particular case, you are denying the create stack operation for IAM resources, right? And we can go deeper into some of those things, and there are a bunch of blogs that you should actually look at and on how to apply at every resource level. So let's go one level more deeper. Let's say now you have a resources which you are using CloudFormation with, and now you want to think about how you can use this CloudFormation at scale. As your company grows, your business has become bigger, and now you have more workloads running on the production, and at the same time you want to go international and expand fast to get that growth for your organization, and you want to go multiple region, multiple accounts, and so forth. So what happens when your environment grows up with AWS Cloud, right? You need to create some boundaries for critical resources. You want to think about the compliance, you want to think about the governance, you want to think about a lot of best practices that can be applied across multi-account and multi-region capabilities, right? So these are some real customer use cases without giving a customer names. And you can see these are some of the use cases where very first one in the list is 2,800 plus accounts this customer has already, and they want to grow to 10,000 accounts because they're expanding very fast to multi-region. They're going to Asia, Europe, and so forth. Now they want to deploy from 9 AWS regions to 11 with multiple availability zones, and there are some of the services that they're using. So this is a kind of a critical situation where, okay, how can I go from 2,800 to 4 times 10,000 accounts, and at the same time I'm going to multi-account? The challenge becomes you can do that manually, but it will take several weekends of your engineering time, and it's also error prone. So how you can get about doing this faster, leaner, and at the same time with less error rate? We have a concept, something called stack sets. I don't know how many of you guys are familiar with it, but with stack sets you can take a single individual template that represent an application stack, including all the clusters and databases, and in one operations you can deploy in a multiple accounts and multiple regions. It's that easy and simple. There are certain things that you have to consider when you're working with stack sets, and there are about 4 core concepts worth discussing here. The first is being that it all starts with the appropriately authored global template that you see in the central left side of this slide. This has to be global template that can go across multi-regions. Then you have to determine how many regions you will implement stack to, and target accounts. In this particular case, you see there are 3 regions and there are 3 accounts each. So we are going to deploy this across 9 accounts. Then you have to determine which account will be the administrator account, right? And by the way, the administrator account has to be assumable, should have assumable IAM role. And you have to go to the IAM management console and provide that privilege. And at the end, the target accounts then delegate trust to the administrator account at the end of that execution of stack set. So basically from single click, you can actually deploy to thousands of accounts as long as you have defined that global template with all the approvals, what you really want to do in terms of applying those best practices across all the accounts. So you can actually execute in a way that you can apply all the security guardrails, and we'll talk more deeper into the future slides. What are those security guardrails that you can apply in stack sets? So there are many use cases, as we discussed, for the stack sets. Some of these are listed in this slide, like where you're setting up a new account for default. You want to have AWS CloudTrail, for example, enabled for all regions for security purposes. You want to have a config rules to be properly tagged. You want to have a KMS keys to be defined, and so forth, right? So there are some of the use cases which is very important when you're going from a small scale to large scale, or you are in an industry like GovCloud, and you want to make sure that all the accounts are following certain policies. Let's switch gear a little bit and let's talk about what we really mean by infrastructure as a code. It actually should be a code just similar to your application stack. You want to define everything in your infrastructure as a code. What it means that it's not just that you use CloudFormation, but you want to track the issues which are in CloudFormation, and you want to have a history similar to what we do with application layer using Jenkins or any CI/CD tool that you're using. You want to have a commits for every single change in the CloudFormation, and we'll talk about that in the future reference architecture. But the idea there is every single check-in triggers a CI/CD build on a CloudFormation to make sure that template has all the things that you needed, and there's no error when you're using that for CloudFormation or for a production workload. You want to use tools and utilities for validations. Something like we have delivered in last year or so there's a tool called CloudFormation Python lint. It's available in GitHub, and you can actually search about it. It basically validates AWS CloudFormation template against the spec, which is very important because we have seen one of the most common error that we see when somebody execute a CloudFormation is that does not apply with the spec itself. So this is a very important utility that I recommend everybody start using it. And you want to include the checks and balances, static code template, as well as the whole 9 yards that comes with automating the entire CI/CD. You should automate the validation more often, and you should log and alert situations as well. On that note, I like to talk about this reference architecture with various of my customers, where you are having a set of customizable tests for logical and functional integrity against the template. And if you look at the diagram, right, it's launch test sets with multiple regions using stack sets, and it runs a post-create test as well as a pre-test using various AWS services like code build, code pipeline, and you can integrate all of that with CloudFormation before you deploy on multiple stacks in your regions. And you can do that. You don't really have to do this testing in production to begin with. Obviously, you should do this reference architecture in production, but start with your dev and test environment, or maybe a staging to see how that architecture goes with your application stack. And you might have to tweak depending on the performance and stuff like that. And the final template is deployed to Amazon S3 bucket when everything is successfully being done, and you can use Lambda, as you see in this diagram, to deploy against all the into S3 bucket. And there's actually a link, if you look at the bottom, and the slides will be shared, by the way. You can go to this link and it provides you the details about how to apply this reference architecture in your own suite of application. So let's switch gear to a second stage of resource lifecycle, which is a configuration management. So once a resource is provisioned successfully, it needs to be managed on an ongoing basis, and it's very critical that we have those things within AWS itself. So these are some of the use cases where you're deploying a version of application across in multiple servers, or you want to have your operating system to be patched. Traditionally, we have seen our customer uses various tools, third-party tools like Chef, Puppet, to get that automation around your operating system layer, right? And it increases your cost, but at the same time, it also increases the complexity, because what you're doing at that point is you are connecting various dots, you're integrating CloudFormation with various AWS services, and not only that, but now you're integrating with those third-party tools. So that's where I think AWS Systems Manager can help, which is a task which is basically a bunch of tasks that you can automate, keeping control on your fleet or the entire fleet. It's a set of fully managed AWS services and capabilities. It really helps you escalate the cloud journey, because you don't really have to learn a new tool or third-party tool and figure out how to integrate. You can actually use this AWS embedded service, which is totally hybrid, right? You can actually use on AWS, but also you can use on-prem as well. Right? Yes, you heard it right, because you can actually use this service in multi-cloud environments too. So we have many customers today who have used this service to manage various of their automated tasks, not only just in AWS and then on-prem. And there are a couple of customers where they have used this service more on-prem and then less on AWS. It's free when you're using on AWS, but you have to pay some minor fees when you're using multi-cloud or on-prem. It's auto-scalable. Basically, as your stack grows, you are actually don't need to worry about how to consume that, because that's a differentiator between other third parties and System Manager. It scales with your infrastructure automatically, and it's AWS optimized for obvious reasons. And right. So let's look deeper into what are these tasks on System Manager, which simplifies. Some of the most common tasks are listed here, which is run command. It safely automates the common administrative task on your instance at scale without SSH. So what you can really do is you can basically do any admin task without SSH or RDP into it. You don't need to have that bastion host anymore, where you need to provide IAM privileges for each user that require access. So that actually eliminates all that heavy lifting that goes with providing that user provisioning and all of that. So inventory is another feature where you can actually collect and query all of that inventory that you have on EC2 instance and any resources that managed by System Manager. So you can actually query just like a SQL-like query to manage thousands of inventory systems that you have. Patch Manager is a very popular service within System Manager that we have seen our customer uses, which Patch Manager you can actually schedule patch installing on your operating system on Linux and Windows based on what is the right time to do it. And you can also schedule in a way that no patch should be installed on a day one the patch is released by the operating system. Basically, you can say that once a patch is stable, 3 days down the line or 4 days down the line, then schedule that patch on your all operating system which are mission critical, because you don't want to have any downtime due to the issues on the patches. The other ones are State Manager, which defines the state of operating system and the configuration that goes with it. It's basically similar to what Chef and Puppet does, but it's much more embedded into your AWS services and things like that. Parameter Store is another popular service within System Manager, where you can centralize that location to store your security keys, control access for easy configuration, that you can use that parameters to be consumed by multiple services and multiple scripts that you have to automate your infrastructure at scale. So how does that work in System Manager? The heart of this whole component of System Manager is documents. That's where you author the configuration to use across System Manager services, starting with the run command and some of those services like State Manager, Patch Manager, and automation. You can also use Parameter Store and other 3 services for further automating along with the documents. But let's take a deeper look what that document looks like, which is a kind of a heart of the system manager. It's a JSON file, and this actually gives you a sample of that document where you are installing a Windows feature, right? You're specifying a package within a Windows environment, and what need to be installed is in the bottom layer or bottom section of this script, where you're having a PowerShell script which will install a specified feature on all your Windows environments in certain time, and you can actually schedule that using System Manager. But that's how the document looks like. And I was talking about the Bastion host and the reference architecture. And the first thing when our customers start using System Manager, the first thing that they do is they just kill their Bastion host. Instead of spending their lot of time and energy on maintaining that Bastion host with resources, they can now use a System Manager using a run command, and they can actually, anybody can have access on that run command. So one of the key component of System Manager is also the agent that you need to install on all the instances which need to be managed by System Manager. So that's the key, because that agent will have information to interact with the System Manager service. So this, when you're having a run command, that run command knows what to do and by who's doing it. You can actually create the logs of things. If somebody like me as engineer is going to the run command and running some executable scripts on certain instances, I will have a complete log, and my administrator will have a complete log of that. So it becomes very easier in terms from the logging and compliance and auditing purposes. This is another architecture where we have seen recently from many customers, they have used System Manager and CloudFormation together with a heavy integration where CloudFormation can deal with all the infrastructure layer, but once the infrastructure layer is done, you can use System Manager at the OS layer to have patch management and automation, anything that you need to do at the granular level. Right, so CloudFormation in this particular case can trigger System Manager automation from CloudFormation, and it's making the CloudFormation wait while the automation document is complete, and it comes back to CloudFormation for further execution. So it's a heavy integration. CloudFormation will wait until all the stuff can be done, and if System Manager fails for some reason, your CloudFormation will roll back everything which is being done by that point, and you can actually check in the CloudFormation console itself why it has failed with certain parameters. So let's switch gears and talk about the third stage, which is a very critical stage in terms of monitoring, and that's where we have seen many organizations struggles, because they're small little automation that you can easily apply using some of the services that we have, for example, CloudWatch, right? Your organization can respond automatically to events by using that service. So these are some of the use cases. Let's say you have your application is experiencing timeout because of latency of the load balancer, or there's a performance degradation due to insufficient CPU capacity, or there's not enough throughput in your database. So how you go about, instead of having a paging done to your sysops, and in the middle of the night your sysops is waking up and trying to tweak the application, there are certain things you could do to address this issue. So for example, in the first use case, if the latency of ELB exceeds 5 seconds over 2 minutes, you can basically send an email to a system administrator that somebody has to take a look. But before that, you can have some certain automation apply to ensure that things are not failing for your end customer. The second one, which is very important, that's where the real use of automation comes in. So if the average EC2 instance CPU usage exceeds 60% by 3 minutes, you can launch another EC2 instance. You can have that done through auto scaling policies and things like that. And the bottom one, where you are struggling with the throughput, you can increase the capacity units on a DynamoDB table whenever there's excessive throttling occurs. All of that can be done through CloudWatch triggers. So CloudWatch can watch these metrics in an ongoing basis, and if the trigger enables, then it can actually automatically spin up new instance or increase the throttling and stuff like that, right? So it becomes really easy for administrator to just focus on the critical issues and not the basic automations as mentioned in this case. Let's look at a couple of best practices now around monitoring and resource changes. There are a lot of guardrails that you can apply, but in this particular case, we will focus on two very common use cases that we have seen in almost 90% of the customer base that we have. And we have seen quite often, when you're using a stack, using CloudFormation, it gets drifted. From the time you spin up the instance to the time where 3 months down the line, various things have happened that many administrators or many users have actually changed the resource directly without going through CloudFormation. So we'll go deeper look into it, how we can solve that. And the second use case is where you want to have a certain CloudWatch alarm dynamically watched by your CloudFormation template itself and take action accordingly. So we'll take a deeper look on that as well. So let's talk about the first use case. Let's say you are a good engineer and you're maybe a good sysop engineer, and you always use CloudFormation template whenever there's need to be change in your resource lifecycle or need to add any resources, delete resources, or modify any attributes associated with the resources. You always use a template to deploy on web app or any of your production stack. However, in reality, that's not a case, right? Not all changes can be planned because we have seen many times that we sometimes explore the resource capabilities using the management console or CLI, and when we try to do some delivery faster, we end up skipping the entire step of updating the CloudFormation template, and that creates a drift from the expected value and the actual value what is there today. But many other times, which is a very common way, what we heard from our customer as a pain point is in case of an emergency, if something breaks over a weekend or over a weekday, they have to have an emergency breakdown and they want to fix something at the resource level itself, and they don't want to go through the whole cycle of CloudFormation. So any changes made outside of CloudFormation to one or more resources contained in a stack that modify expected configuration value of resources or delete that resource results in the configuration drift. So that's basically a definition of configuration drift. How we go about solving that? Now the good thing is, last year we have launched CloudFormation configuration drift, and it's already GA last year. With a couple of clicks from your management console, you can actually easily see how much of your template in your CloudFormation is being drifted from the expected value. And I highly recommend running this once a week, right? Or you can actually automate that process as well. But what it gives you is some view like this, where you can see what is being removed in anything that is being in red, what is being added as a resources, and what is being changed. And based on that, you can actually take action. You can either roll back to the expected value of something changed which you really didn't want it to change, or if you really wanted to have that change but you want to update the template, you can take those actions right from the console itself, right? So it becomes really easy for the administrator to actually know those changes and take action based on what is being found or observed. Let's look at the second use case. Many times we got into a situation where we want to roll back a new patch due to degraded app performance, right? So let's say we deployed a new patch or new application service, but now with that new application service, we have seen our application performance has degraded. And now there's a paging gone to everywhere, and everybody is struggling to see, hey, what went wrong? So how we can eliminate some of those situations? The good thing is now CloudFormation can automatically roll back the entire template or any changes in the resources which has triggered a degraded app performance. How does it work? It basically watches a CloudWatch alarm closely. It waited until the CloudWatch triggers some output in a way that the CloudFormation template will know that the performance is degraded or it's as expected, right? So you can actually automate the entire thing in the template itself, and you can monitor these alarms while the stack is being updated. So let's look at how does that look like. So this is a build service rollback JSON file. It's basically a CloudWatch alarm which look for a SQS queue in terms of checking on the performance. And then you can actually, when you're updating a stack, you can actually add a rollback trigger at the end. So if you look at the bottom of that, which is highlighted in bold, rollback configuration, and you pass that JSON file. So now CloudFormation template knows that when it's executing, it needs to watch for that CloudWatch alarm to make sure that this is being executing the way it is being expected. So in console, what you will see if that CloudWatch alarm fails and it comes back to CloudFormation, the update starts with the status reason being listed here, which says that CloudWatch alarm was state of this particular parameter. And you can actually customize that reasoning based on your need. But the idea there is that with this kind of implementation, you don't need to worry about outages based on your new patches, and something is being missed out of your CI/CD cycle, CloudFormation will capture that through CloudWatch, and you can automate the entire process, and this will roll back. Let's look at the fourth one, which is the heart of this particular summit, governance and compliance, how you can actually have FedRAMP and HIPAA and so forth apply to some of these scenarios. So let's start with the compliance talk first, right? How does compliance work in many organizations today, right? And I'm talking about the big giants that I referred earlier. From what I have seen, it might look like a fire drill. And I've used to work in some of those big giants several years ago, but many times we have seen there's a fire drill. Okay, we are doing audit across all of our organization, and next 3 weeks we have to go through compliance situations and compliance scenarios, and every processes, every system should be compliant to certain industry standard, right? And it becomes really caveat, and because during those 3 to 4 weeks, nobody's innovating. Nobody is doing anything productive. All they're making sure is compliance is ready. So what if there was a way to codify these policies, like compliance as a code, right? Have these policies automatically trigger and continuously being watched, and it will give you notification in the form of some dashboard. We have a service there called AWS Config. I personally call it as a configurator auditor, if you will. It basically gives you a scenario where you can actually define all these rules on what compliance is important to you, and there are many rules which are predefined, and it will give you those things. How does that work? So AWS config and config rules is, let's say you have a lot of resources on your AWS and you're changing that frequently. AWS config will normalize that based on the config rules, and you can get notification in terms of API access, and you can actually see that in the history. And it's a continuous recording. It's basically very similar to, if you think about it, it's a configuration drift, which is more reactive when you are clicking through the CloudFormation template and from the console. This is more proactive. This basically gives you notification on an ongoing basis. As soon as something is changed on your infrastructure, it will give you notification that, hey, something has changed. And you can define many of these record and monitor stack changes in the config itself, and you can actually apply with a current and history stack. You can have auto scaling enabled. There are a bunch of rules that comes embedded into some of these things. This is the best part about the service. It gives you a timeline or a dashboard on what resource has been changed and how many times it changed in a day. In this particular case, you see on 19th of November, this DynamoDB table has been changed 4 times, and who changed it, and what is being changed, and it gives you that timeline view, so which is really awesome for administrators and SysOps engineers. You can drill deeper. You can look at what resource attribute is being changed from where to what and at what timeline, and then you can make a decision whether that was relevant to any issues that you're seeing on the production instance, or whether you really wanted the change to be replicated across all the clusters, things like that. This is a pre-built rule which is highlighted here. It's highly recommended, I would say, enable this rule automatically to send SNS notification for any stack changes. This is highly recommended for SysOps and administrators. And there are many other embedded rules which are there, and I highly encourage you guys to take a look in your leisure time, and which will help you guys to automate this particular service. This is another dashboard which I love. It gives you, based on what compliance has been chosen and how much are you compliant based on, let's say you're HIPAA, you're in healthcare, you wanted to make sure that all the 40, 50 compliances are being automated, and then you can see in this dashboard how many are not, and then you can drill deeper on see why it is not, and then you can work about with your engineers to get those automated. All right, so we talked about best practices. We talked about how you can consistently scale, and we also talked about complexity. But when you talk about the government and the gov cloud and all of that, it's still, there's a challenge in our customer base where it's very hard to govern whether whatever compliance issues that we have is being automatically being replicated across multi-account and multi-region, because most of these customers are across globally, right? These are some of the multi-account challenges that we have seen, because the paradox of choice is the biggest one. Our SAs, professional services, TAMs, they spend hours and hours with our customer to understand their design decisions and based on what they need, because there's a lot goes when you're making those multi-account decisions, starting from the network architecture to direct connect to multi-account pairing, user access, log aggregation, parsing, and so forth. There's a lot of decision making happens in that, and it's very hard to automate that, right? So when you're dealing with that level of complexity, and the ongoing management becomes really tricky, because you want to centrally manage that. You want to see which account is not being compliant, which account is not being governed, how you can make that more governed as you scale up. That's where we launched in last reInvent AWS Control Tower, and I think they recently went GA, or they're about to go GA later this month. It provides a consistent and simple multi-account management, which is secure, and you can actually apply across thousands of accounts that you have or n numbers of regions that you're using. It automates the entire setup for you, right? It actually gives you a list of 40 plus guardrails that you can actually apply. What it means is that whenever the new account is spin up using AWS Control Tower, those 40 plus guardrails, security guardrails, will be there for you, so you don't have to worry about it. The entire step of being compliant, following the best practices, especially in the government sector or specific industries like healthcare, all of that can be automatically done through some of those blueprints. I think with the GA, we're going to be having some best practices blueprint, but I think by the end of this year, there's a plan to customize those blueprints based on your own customer needs. So you can actually start having those custom compliance based on what you want for your organization to be compliant for using this particular service. You can enforce policies, as I mentioned, and you can have a dashboard view to see out of 1,000 plus customer or 1,000 plus accounts, which ones are being compliant, which are being governed, where are the issues. You can actually have that entire dashboard. So these are some of the Control Tower key features, right? You can automate the entire thing using a landing zone. It can scale as your account creation creates or scales up. It can have a account provisioning wizard, so you can actually use this wizard to automatically do that. But the main thing that this service provides is a set of best practices and guardrails. You can actually prevent and you can detect all the guardrails and actually add on the top of best practices. And it's very easy to use. And we probably will be doing some demo in some of the other sessions as well around Control Tower. I highly encourage to attend those sessions as you pursue with this AWS Summit. Last but not the least, the resource optimization. It's very important for all the application stakeholders. As the resource is being provisioned, you want to make sure it is being used for cost efficiency, performance, and things like that, right? So these are some of the scenarios where we have seen very common in our customer base is, are there any provision resources that are being underutilized? Many times we have seen we provision resources, but they're sitting idle and do nothing. Are there ways to reduce charges? Are there any suggestions for improving the performance? And the main one, the service limits, right? How far am I before I reach throttling errors, right? This is a very, very common use case. For that purpose, we have a trusted advisor which provides the best practices automatically in 4 categories: cost optimization, security, fault tolerance, and performance. It basically gives you the high level overview, what is done in your stack, following the best practices, and what is not. So this is how it works. So if you're a business leader or a developer, it basically checks and scans the entire stack for you on an ongoing basis, on a proactive basis. You don't have to trigger this, but you have access to Trusted Advisor 24/7. So if you log into our management console, you can search for Trusted Advisor service, and it will scan the entire stack for you, and it will give you recommendation on 4 pillars that I mentioned in the last slide. So for example, your RDS instance is idle and that's costing more money for you, so you should shut it off. This particular service will give you that level of granularity, and it will give you some recommendation to save some dollars. And service limits, let's say you are 90% on the threshold before you start seeing throttling. So instead of waiting until the throttling happens, you want to have your case open saying that, hey, I'm reaching 90%, I want to be proactive, I want to open a case to increase my service limits, stuff like that. You can automate and be more proactive in some of those scenarios. You can subscribe to Trusted Advisor notification via email too. So anytime some critical things are being watched by a Trusted Advisor or being observed, it will send you a notification, so it's more proactive way. And there are ways to actually build a Lambda function as well, where you can automate the entire end-to-end cycle if you use this Trusted Advisor. This is very, very critical service if you want to automate in your entire resource life cycle and you want to optimize for scale. So in conclusion, right, infrastructure as a code on AWS. These are some of the 5 stages that you can actually apply and try to automate using some of these services. So CloudFormation for resource provisioning, you can use System Manager for configuration management, CloudWatch for monitoring, AWS Config and Control Tower for governance and compliance, and at the end you can use Trusted Advisor, which is another proactive service that every SysOps engineer should be looking at for resource optimization. With that, thank you so much, and feel free to ask any question. I will be here for another few minutes, and please complete the survey for the feedback.